Good day, grade 12 learners. Welcome to today's technical science lesson. My name is Thabang Mongatani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saipono Discovery Center. Grade 12 today we'll be looking at electric circuits. Remember last week we were busy with capacitor and capacitance. We are continuing today with our electric circuits. As a reminder, grade 12, the paper 1 in prelim and in final exam will be structured in this way. It will be divided into mechanics, electricity and magnetism, and wave, sound, and light. Mechanics will take 93 marks, which is 62%. Electricity and magnetism, it will be 33 marks, which is 22%. Wave, sound, and light will be 24 marks, which is 16%. Our paper is out of 150 marks and is for 3 hours. Section A in our paper is multiple choice, which we have 10 multiple choice questions, and then it gives us 20 marks. Section B, which we call a structured question or long questions, is 130 marks. And the total is what? 150. You'll be writing for 3 hours, and after 3 hours, you'll be asked to stop writing. The topic that we'll be looking at today is electric circuits. It's about 20 plus minus 20 marks in an exam. We know that as we're talking about electric circuits, we'll be talking about more on power, energy, and energy. And then because we're dealing with what? The power, more power that we have, we got it from what? Eskom. You can see the diagram of one of our the plant, and as you see on my right, that is a prepaid meter for electricity. After you bought electricity at home, then you punch it in, and then so that you can start using electricity at home. But the electricity that you buy, where does it come from? It comes from the picture that you see on the left. Are we together, grade 12? Yes. This is where electricity is being produced. Okay, grade 12. Before we get to our today's lesson, we need to go back and see if we can get anything that can help us to continue with the lesson today. And we found that the lesson today, pre-knowledge of the lesson today, which is very, very important in today's lesson, is Ohm's law, which you did in grade 11. The first thing that we need to know in Ohm's law is to do what? They say state Ohm's law in words. What is Ohm's law? How do you state Ohm's law in words? The potential, we say Ohm's law states that the potential difference across a conductor is directly proportional to the current in the conductor at a constant temperature, meaning that we should not allow the temperature to change, whether to increase or to decrease, because it will affect the potential difference and the current. Remember, grade 12, when you increase the temperature, you are decreasing what? When you increase the temperature in the wire, you are decreasing the wire's what do you call resistance? Yes, resistance. And then we continue by saying, determine the relationship between the current and the voltage and the resistors. This is what you did in grade 11. At a constant temperature. Every time we keep temperature constant when we're dealing with Ohm's law, because we know that the temperature, if you increase temperature or decrease the temperature, you are increasing the particle lattice of the wire. We continue by saying, we're solving the problems of Ohm's law by using this formula here. This formula that you see here, it says R is equals to V divided by I. Then R, our R is what? Resistance. And is measured in what? In ohms. And the symbol for ohm is what? We have something like this. I don't know, we used to call it omega. We used to call it omega. But it's ohms. Then we have V. V is what? Potential difference. And it's measured in what? Is what? V is potential difference. And it's measured in what? In volts. Which the symbol is V. The symbol for V, the symbol for volt is V. Are we together, grade 12? Then I. I is current. I is for current and is measured in ampere. And the symbol for ampere is capital letter A. Remember grade 12, don't confuse this A with the A that we used last week as an area. This is not an area, it's a symbol for current, to measure current. Are we together, grade 12? Yes. Grade 12, before I continue, let me remind you that we have our WhatsApp line where we have our technicians that will help us with the questions. If you have any questions, please WhatsApp it on 063 269 3655. Let me continue. Let me repeat it. 063 629 3655. That is our WhatsApp number. And then let's continue by saying we'll be looking at resistors that are connected in parallel and that are connected in series. And then we know that when we're counting the number of resistors that must be in the circuit, it must be maximum of 4 resistors. Are we together? In grade 12, we are not allowed to have more than 4 resistors in one circuit. We must have maximum of 4. And then we say, use the series and parallel resistors in combination with Ohm's law. That means this R that you see here, we're gonna use to calculate this R. We'll be using it in series where we'll say R1 plus R2, or in parallel, this is series connection, and then parallel connection will be using what? 1 over R. 1 over R is equals to 1 over R1 plus 1 over R2. This is the formula that we use to calculate the equivalent resistance in a parallel connection. And then sometimes we are forced to add both parallel and series together, because when we have a circuit where both parallel, the resistors are connected in both parallel and series. You will see when we come to our problems. Okay, grade 12. Let's continue with grade 12 work now. We say grade 12 exam guideline. It's when it comes to electric circuits, we say you must be able to define what is power. You must know the SI unit for power. You must know practical units for power. You must be able to solve problems that by using this formula and this formula, you can see all these formulas, they are for power. That means power is very, very important in our lesson today. Can you see all four equations are for power? And then we say we use all these four formulas to calculate power, work or energy, time, voltage or potential difference, current, and resistance. Are we together, grade 12? We must be able to calculate power, work or energy, time, potential difference or voltage, current, and resistance. Are we together, grade 12? Yes. Again, we say from exam guideline, deduce that the kilowatt hour, this is kilowatt hour, is this, refers to the use of 1 kilowatt of electricity for 1 hour. That means in 1 hour, you will be using 1 kilowatt of electricity. Are we together, grade 12? And then they said calculate the cost of electricity using given the power specifications of the appliances used as well as duration if the cost of 1 kilowatt hour is given. We will give you the time for 1 kilowatt hour, and then you are able to calculate what the cost of electricity. You'll see when we come to our problems, grade 12 is no-strings mesh. As I'm talking now, you might get confused, but when we're doing the examples and the problems, that's when everything will be cleared out. Okay, grade 12, we come to electric circuits. They say define power as the rate. Can you see how important the rate is? The rate is even written in weight. Is the rate at which electrical energy is converted in an electric circuit. Is the rate at which electrical energy is converted in an electric circuit. Are we together, grade 12? You must mediate all these definitions. You must know them by heart. All of them, not only power, but all the definitions on all the laws that we have in technical science. You must know them by heart so that when exam comes, you don't struggle when they say define or state any law. Okay, grade 12. And then, what does it mean when you say power is the rate at which electrical energy is converted in an electric circuit? The rate, can you see this? Let's look at this formula here. Or I can just go back a little bit. Can you see this formula here? This is the formula for power. That is the formula, is a definition for power because it talks about the rate. The rate, when you see the weight term rate, you must know that we divide by time. Always when you see the rate, you must know that we divide by what? By time. Okay, grade 12. Let's continue. And then the SI unit for what? For power is watt. Put together is W-A-T-T is watt. The SI unit for power, that means power is measured in watt. Then the symbol for watt is caps W. Is capital letter W. Are we together, grade 12? Yes. Now we continue We continue. We're saying, what is 1 joule of an energy converted in 1 hour? 1 watt is 1 joule of energy converted in 1 hour. Okay, thank you. And then we say practical unit for power is kilowatt hour. That means when you go and buy electricity, you don't buy electricity in watt. You buy it in what? Kilowatt hour. Are we together? Yes, the power that you buy at Eskom, you buy it in what? In kilowatt hour. Okay. We use the power equation to calculate power, energy, time, current, potential difference, resistance, and the heat produced by the current and the resistance. Like, you'll ask yourself, what is the heat that produced by current and resistance? Okay, grade 12, this is it. When you switch on the light in your house for longer, and you go and touch the bulb will be hot. What makes that to be hot is what, as the current is moving through the resistor, because the wire that they used to make that bulb is an example of what? Of a resistor. It is an example of a resistor, and it has what? Resistance. That is why at the end you'll find that the bulb is hot. Or heater. What makes heater to be hot? The same scenario. The current is moving through the wire in the heater that is used to make that heat. And then because that wire is a resistor, a material, then it doesn't allow current to flow through it easily. Then as the current flows through it, it collides with the particles of the wire. Then it forms what? Heat energy. Are we together? Then in grade 12, we'll be able to calculate that heat energy. Are we together, grade 12? Yes. The formulas that we'll be looking at, and these formulas that you see, grade 12, they come straight from exam guideline. Are we together? I just cut and paste them from exam guideline. That means they are very, very important, grade 12. They are very, very grade 12. You can see this one. Let's start with this one. This is P that you see here is what? P is for power. W is for what? Energy, or the heat that is formed by what? Current and the resistance. Are we together? That is W. And changing T is what? Is time. And in this instant, time is not measured in seconds, grade 12. Time is measured in hours. Are we together? When we come to electrical power, with time we measure it in what? In hours, not in seconds, as we've been doing in previous lessons. Okay. Now we come to this formula here. P also is still what? Power, and is measured in what? And then W is energy, or the heat that is formed by what? By resistance and current, and is measured in what? Joules. And then time is measured in hours. Then even power here is still measured in watt. And then V is measured in volts. Is the voltage or the potential difference. If you don't want to say voltage, you can say potential difference. And it's measured in volts. And then which is V, caps V. And then I that you see here, it's current, is measured in ampere. And then the symbol for ampere is caps A. Are we together? It's capital letter A. Then we go to the next formula. The next formula says is P is equals to I squared R. That means P is still power. I here is what? Is current, which is measured in ampere. And then R is what? Resistance. Are we together? R is for resistance and is measured in ohms, as we said earlier. And then we come to this one here. This one you can see P is still power. V is a voltage or potential difference. And then R is resistance again. Grade 12. Then we go here. This formula that you see here, W is energy or what? The heat that formed by what? That caused by resistance and current, and then is measured in joules. Then we have a V here. V is still potential difference, and then Q is charge. Is what? Q is charge. And it's measured in what? Is measured in coulombs. Are we together? Or capital letter C. Are we together, grade 12? W is still energy, and then V is still what? Potential difference, and then I is current. Then change in time, we know that is the same as this one here, is measured in hours. Are we together? And then W here is still energy, I current, R resistance, changing time. Can you see? W here, energy, V potential difference, time, resistance. Can you see, colleagues? And then we know the symbol, all the symbols that are represented in all these formulas, and their units, the SI units of each and every letter that is represented in these formulas. Grade 12. If you have any question, please don't hesitate. WhatsApp there your question to 063 629 3655. Okay, we continue with the formulas because it's very, very important that you know all these formulas. Grade 12. This formula here, we've seen it. This we have seen it. This we have seen it. This we have seen it. And this we have seen it. Are we together, grade 12? And it is very, very important to know each and every letter. What does it represent? Because you must know what does it represent, and you must know the unit, the SI unit of that letter. So that when you choose the formula from the formula sheet during exam and prelim and final exam, you know that you are choosing the correct formula because you have a mark, 1 mark, for each and every correct formula that you will be choosing. You have a 1 mark for each and every correct formula that you will be choosing. Are we together, grade 12? Yes. Okay, let's start again. P we said it stands for what? It's for power and is measured in watt. Are we together? And then the symbol for watt is W. The symbol for watt is W. Caps W. And grade 12, please don't confuse this and this. Are we together? They are both W's, but please don't confuse them. This is what? This W that you see here stands for what? It stands for the heat that produced by resistors and current, and is measured in joules. Are we together? Or you can say it's an energy. Are we together? And it's measured in joules. Are we together, grade 12? Yes. Okay, now we come to change in time. That small triangle that you see there, it means change. The triangle means what? Change. And if you see triangle T, that means it's change in time. Are we together? We must have time interval. It forces us to have what? Time interval from 3 seconds to 3 hours. That is a time interval. Are we together, grade 12? Yes. And then our time at this instant we said is measured in hours. And then the symbol for hour is small h. Is small h. Why is it small h? Because it's not named after any scientist. Are we together? It's not named after any scientist. Okay, grade 12. Yes. Let's continue. Then we say V stands for potential difference or voltage and is measured in volts. Symbol for volts is what? Capital letter V. Are we together? Capital letter V. Okay. I stands for current and is measured in ampere, and symbol for ampere is capital letter A. Then we go to R. R is what? Stands for resistance and is measured in ohm. And this is the symbol for ohm. Are we together, grade 12? Thank you. Let's continue, grade 12. We have our first example, and it is a multiple choice question. Grade 12, when we answer multiple choice questions, we don't close our eyes and then round around, make a circle around the letter, and then you word whatever and point, and whatever you point is the correct answer. That is not how we do how we answer our multiple choice question. Our multiple choice question, how do we answer it? We first read the statement and read it again until we understand the statement. And then thereafter we go to the question and we look at what is the question? What is question want us to do? And then after we understood the question, that's when we go to the answer and see which one is very, very close to the answer. And then thereafter, after we've seen that these two that are close to the answer and the rest are out of the answer, then we do what? We throw away the one that are far from the answer. Then we left with only two that are close to the answer. Then that one, it gives us 50% chance to get it right. Then whatever we're going to choose, then we know that we are very, very close to the correct answer. And then it is very, very easy for us to choose the correct answer. Are we together, grade 12? Yes. Okay. This is what we're going to do now. We're going to go through the question together. It says, consider the circuit diagram below. Bulb A, B, and C are identical with the same resistance. Can you see? In bulb, we have what? Resistance. Bulb A, B, and C. Can you see? Then they say, we understand the question now. Consider the circuit below. Okay, this is the circuit below. We must consider it. And then bulb A, B, C are identical with the same resistance. That means they have the same resistance. If here is 2 ohm, that means here is going to be 2 ohm and here is going to be 2 ohm. And if here is 5 ohm, this is going to be 5 ohm and this one is going to be 5 ohm. That is what we mean when we say they are identical with the same resistance. Are we together, grade 12? Yes. And then now let's go to the question. The question says, which one of the following is correct when the switch is closed? Is it A? Is it B? Is it C? Is it D? Which one is correct concerning the current? Okay, we found that the current that will pass on A is equal to the current that's going to pass to B and C. Are we together? Hear what I'm saying? The current that's going to pass in A is equals to the current that's going to pass in C and in B. That means the two current, these two resistors, when you add their current, they will give you the current of A. Then, which one is correct? Let's look at A. A says the current in A is equals to the current in B. They say the current in A is equals to the current in B. That is no, because the current that it passed in C and the current that is going to pass in B are equals to the one that is in A. Are we together? Then let's go to C. C says the current that's going to pass in C is less than the one that is in B. That is wrong answer. It's not correct because of what? We know that this one is bigger than, is bigger than C and is bigger than B. The current that passes in A is bigger than the current that's going to pass in C and is bigger than the current that's going to pass in B. But it's equals to the current that's going to pass in C and B. Are we together, grade 12? Then D, it says the current that is going to pass in A 2 times, when you multiply it by 2, is going to give you the current that is going to pass in B. That is still no, 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 no. That means our answer is what? Is B, because of what? The current that's going to pass in A is greater than the current that's going to pass in B. Are we together, grade 12? Yes. Any question, grade 12? WhatsApp it, please, and then we'll answer to it. Okay, we have another example, and which is multiple choice. It says, which one of the following combination of SI unit is equivalent to ohm? Wow, is equivalent to ohm. Grade 12, I want us to go back to the formulas. Which one has a resistor? Is this one. Can you see? We have P is equals to I squared R. Let's go back and check which another one that has R. Is this one. Which is what? P is equals to V squared over R. And then we have this one also. Which says W is equals to I R change in T. Is it I squared? Yes, it's I squared. I squared, yes. I squared. Can we see grade 12? Let's start with this. Here, when you make R the subject of the formula, we will be having what? R is equals to P over I squared. And here, when we make R the subject of the formula, we found that is what? V squared over P. Can you see? And here, when we make R the subject of the formula, we found that is what? Is R is equals to W over I squared change in time. Can you see? Yes. Those are, and then that means here we know that ohm, R is ohm again. The SI unit for R is ohm. That means our ohm is equals to joules divided by what? Ampere squared hour. Are we together? And then we go here, this one here, we know that ohm is equals to watt ampere squared. Can you see? And then this one here, we're gonna say ohm is equals to volt squared divided by watt. Can you see? Then let's check the answers that we have. This one, it says joules per coulomb. This one said volt per ampere. Volt per ampere. And then this one says joules per coulomb. This one says coulomb per second. This one said volt multiply with ampere. This is already out. Then we see here, let's look at A. A, it says what? Volt per ampere. Which one can we deduce to give us volt per ampere? Let's look at this one here. This, we said, is the same as what? If we say V into V, D divided by what? This is V squared again. V multiplied by V is V squared. Then we say what? We're going to have what? For W, then we have what? What is our W? Then W, we're going to have volts and multiply by what? Ampere. That means our W is V multiplied by I. Are we together? Then when we say we look at that, then this volts will cancel this volts. That means our ohm is volts per ampere. It's volts divided by ampere. Are we together? That means our correct answer is A. Correct answer is A. Are we together, grade 12? Yes. Can you see how we worked it out? Can we take our 1 minute? Okay, welcome back, grade 12. We said the answer is A for this problem because of what? We looked at the ohm is equal to volt squared divided by W, where we found that W is equals to what? Is equals to V multiplied by ampere, and then we say now V squared over V ampere, then cancel this, we left with what? V over A. This is our answer. Are we together, grade 12? Yes. Okay. Now we see another multiple choice question. The question says, the minimum value of the resistance that can be obtained by connecting two two 4-ohm resistors is, if we add, we have two resistors. This is 4 ohm and another resistor that is 4 ohm. That is 4 ohm. Both resistors are 4. What is the minimum value that we can get when we add these two? Whether we add in series or in parallel. What do you think, grade 12? Let's do it. Let's start with connect them in series. When we connect them in series, that means we're going to say R equivalent is equals to R1 plus R2, which is equals to 4 plus 4, which is going to be 8 ohm. Can you see? Is it this the minimum value in the list that is given? No, it's not, but it is what? The highest value. Are we together? It's not the minimum. Then let's see if we add them in parallel. Parallel, it says 1 over R equivalent is equals to 1 over R1 plus 1 over R2, which is the same as 1 over 4 plus 1 over 4. Remember, this is 1 over R equivalent. And then thereafter, we have 1 over R equivalent is equals to 4. Then we say 4 goes how many times into 4? 4 goes how many times into 4? It goes 1 time. 1 multiplied by 1 is 1. Then plus 4 goes how many times into 4? We say this 4 goes sometimes into this 4. It goes once, and then this 1 multiplied by this 1 is going to give you what? 1. Then we have 1 plus 1 is 2 over 4. Can you see? Then we have what? We have let me just erase. Erase this one here, because 1 over 1 over R equivalent is equals to 2 over 4. Therefore, R equivalent is equals, can you see now? We are swapping them. We're swapping R equivalent with 1, and we're going to swap 4 with what? With 2. And then anything divided by 1 is that thing. Then we say now R equivalent is equals to 4 divided by 2 is what? Is 2. Can you see? Then that means our answer is what? Is B. Are we together? The minimum value that we can get in order to add these two resistors that are the same, they have the same resistance, is what? Is 2. Okay, grade 12. Let's continue. If you have any question, please don't hesitate to WhatsApp us. Okay, we're coming to long questions. We're coming to long questions. The circuit diagram shows 3 resistors connected to a battery. Let's see. This is the first resistor, the second, the third. Can you see? They said 3 resistors connected to a battery with a negligible internal resistance. 2 resistors of 2 and 10 ohm are connected in series. You can see this one and this one are connected in series. Are we together? Yes. Then this combination is connected in parallel to 4. That means when we look at this as a set, not individually so, and we look at this, they are connected in what? In parallel. Are we together? Yes, they are connected in parallel, which is the functioning at a power which is functioning at a power rating of 36 watts. You can see 4 ohm, it has what? The power of what? 36 watts. Then the first question says, let's look into the question. First question says, define power in watts. Define power in watts. That is number 1. Number 2 says, calculate the following. We're going to calculate what? Current. They want us to calculate what? Current. They want us to calculate what? Potential difference across 4 ohm. They want us to calculate current that is passing on this ammeter. They want us to calculate what? A potential difference across what? 4 ohm resistor. They want us to calculate current in the 10 ohm resistor. That is number 3. And lastly, they want us to calculate the current in the battery. This is the battery here. Can you see the symbol for the battery? Can you see all the symbols here? Are they looking familiar? Do you know them? Have you seen them before? Yes, you must know them. This is the battery. This is the symbol for what? For resistance, and this is for armature. Are we together, grade 12? Yes. Now, let's go. Number 1, it says, define power in watts. And then what is power, grade 12? We said power is the rate at which energy is converted in a electric circuit. Are we together? Let's go to our solutions. It's here. It says power is the rate at which electrical energy is converted in an electric circuit. Are we together? Then number 2, they say calculate current in an ammeter. How do we calculate current in an ammeter? There we go. We use this formula because we know we're given what? Resistance, isn't it? We have resistance. We are calculating. This is what we are calculating for. And then this is power. We have power also. Then we write down the given data. The given data is what? Power is equals to 36. Then resistance, R1 is equals to 4. R2 is equals to 10. And what? 6. R3 is equals to 6 ohms. Are we together? Those are what we are given. Ne? Yes, 4, 6, 10. 4, 6, 10. That is what we are given. Okay. Now, they want us to calculate what? They want us to calculate current. They want us to calculate current. And by looking at the answer there, because power is 36, yes, we put 36, we substitute there. Out together, we put what? 36. And then because we are using the 36 is the one, is on which resistor? 4 ohm resistor. The 36 is the power that powered the 4 ohm resistor. Are we together? Then that's why we use for R, we use 4. Are we together? Yes. And then you ask yourself, how did I get 3 there? 3, it comes from here. 36 is equals to I squared multiplied by 4. Then I divide by 4. I divide by 4 this side. Then this 4 cancel this 4. I left with what? I squared is equals to 36 divided by 4. How much is 36 divided by 4? Is 9, isn't it? It's 9, yes. And then for me to get a 3, I have to put the square root on both sides. Then it will be square root of 9 is 3 ampere. 3 ampere. Are we together, grade 12? Yes. Any question? Okay. Let's continue. The second question, it says, calculate the potential difference across 4 ohm. Then, this is what we have. You can see here, we have a 2 methods in which you can calculate the answer. And both of those methods, they give us the same answer. Easy method is P is equals to VI, which is what? P we know is 36 is equals to V multiplied by 3. Then V is equals to 36 divided by 3, which is 12. How would you get? Because you divide both sides by 3. Then it gives you 12 volts. Or you can use this one that is in your exam guideline, which says P is equals to V squared R. We know that 36 is equals to V squared multiplied by 4. Then we divide by 4, then we go and get what? We say V squared is equals to 36. What's happening? Is R. Oh, this is divide, not multiply. It's supposed to be divide, not multiply. I can see that something is off. Yes, let's go back and see. Can you see this formula here? Is divide, not multiply. It's divide, not multiply. Is divide, not multiply. Can you see? From here, okay, let me just erase everything. We say here, this is fine. There is nothing wrong with this one, the first one. The problem is with the second one. P is equals to V squared over R. How would you get? Then from there, we're saying 36 V squared divided by 4. Then we multiply by 4. We multiply by 4 this side. Then this cancel this. We have V squared is equals to 36 divided multiplied by 4 is what? Is 24, 4, 12, 14. Then we'll have what? 144. How would you get it? Is equals to 144. Then square root V squared. Square root of 144 is 12 volts. How would you get? Yes. Then that is the answer that we get. Now, this is, you're going to say what? Divide here. And then is divide here. Is divide here. We divide here. How would you get it in order to get the correct answer? I apologize for that, grade 12. Apology for that. Then let's go back to the question. It says, number 3, calculate the current in the 10 ohm resistor. 10 ohm resistor. Then that is our calculation. We calculate what? Current in our 10 ohm resistor. Remember this formula that you see here is the formula that we used in what? That we saw in grade 11. Ohm's law. We say R is equals to V over I. Are we together? Then because our R is what? They say what? R is 16, which is equals to, the voltage is 12 plus, and then current there is going to be what? The current is I. Then from here, we just say what? We're saying multiply by I, and then I cancel I. Then we're left with what? 16I is equals to 12. Then divide by 16, divided by 16. Then we have 16 cancel 16. Then we have I is equals to 12 divided by 16, which is 0.75 ampere. Are we together, grade 12? Yes. And then you ask yourself, where does this 16 comes from? Okay, 16, we remember in our circuit, we have what? We have two resistors that are connected in series, the 6 ohm and the 10 ohm. When you add them together, then you get what? 16. Are we together, grade 12? Yes, that we get our R as 16 because of resistor 6 ohm and 10 ohm. Ne? Yes, grade 12. And then lastly, the last question says, calculate the current in the battery. Calculate the current in the battery. Now, let's go. Calculate the current in the battery. How do you calculate the current? You just take the total current that is in the circuit. Are we together? And then that is going to be 3. Remember the first current that you calculated, it was 3. The one that is passing in what? In 4 ohm. It was 3 ohm. Then now we just take that 3 ohm, we add to this current that is passing through 4, 6, and 10. Are we together? We started with 4. The current that is passing in 4 ohm is how much? Is 3 ampere. And the current that is passing in 10 plus 6 is what? Is 0.75. Then we just calculate, in order to get the total current that is in the circuit, we just add both current that are passing in each resistor. Then we get what? I total, which is gonna be what? Which is gonna be 3 plus 0.75, which is going to give us 3.75. There is nothing wrong with the answer that we have. Are we together, grade 12? Yes. Then let's look at this interesting question, grade 12. This is very, very interesting because we're dealing with the appliances that you and me, we know them. We have them in our homes, at our homes. Let's look at the devices first. We have a cell phone charger. We have a cell phone charger. We have a cell phone charger that is what? Is using 240 volts and 150 milliampere. Are we together? It's using what? 240 volts and 150 milliampere. And the kettle, an electric kettle, which is using 220 and 600 watts. Wow. Television, TV, is how much? 60 watts. Globe, the old type one, is what? 60 watts. No, it's 100 watts. Energy saving light is 15 watts. Can you see? That means the old globe, they used to eat a lot of power than the one that we're having today. That is good for the technology. Can you see now? Our technology can take what used to cost more energy, and now we use what doesn't cost more energy. Okay, the computer, which can be a laptop, it uses what? 230 volts and 0.5 ampere of current. Electric iron is 1.4 kilowatts. Can you say how much it is? 1.4 kilo. Kilo, it means 1,000. 1,400 watts. 1,400 watts. Wow. And 220 volts. Are we together? Yes. Now they say the question, let's go to the statement. The statement say, study the energy consumption of the electrical appliance in the following table. Then the first question says, define the power, the term power as it relates to electrical circuit. That is the same definition that we gave before. Power is the rate at which electrical energy is converted in an electric circuit. Are we together? Power is the rate at which electrical energy is converted in an electric circuit. It doesn't change now. Okay, number 2, they say calculate the power requirements of the mobile phone charger. Calculate the power requirements of the mobile phone charger. We know that we have a 250 volts and 150 milliampere. This is what potential difference, this is current. Can you see? Yes. Let's go. That is definition for power. This is formula that we'll be using. Can you see? P is equals to IV, which is power. And then now you'll be surprised with this. 150 times 10 to the exponent negative 3. Okay? When you see M, milliampere, small m, that means you must know that is equals to times 10 to the exponent negative 3. Are we together? The same way as micro. When you see microampere, you'll be saying what? Times 10 to the exponent negative 6. Can you see? Yes, that is how it works. Because of this m, then we put what? Times 10 to the exponent negative 3 to 150. Are we together? That is given. Then we found that when we use our calculator, we found that the power that is being used by a cell phone charger is how much? Is 36 watt. Are we together? Is what? 36 watt. Negative 12. Thank you very much. Let's continue. The third question says, which device has the highest power requirement? Which one has the highest power requirement? Which one do you think? Is it electric kettle or an iron? Let's see the answer. Iron is the one that has more power requirement. Is the one that eats your power at home more than any of these devices that we have here. Are we together? Which devices? Okay, we looked at that. Calculate the current that the electric kettle will feed from the supply. Electric kettle, we have what? 220 volts and 60 power of 600 watts. That is what we are given. Are we together? We said power is given is what? Is 600 watts. And we have what? The voltage, the potential difference that is needed, we said is what? Is 220. Then from there we can calculate what? The current. Our given data is what? Is power, which is 600 watt, and V, which is 220, and an I that we are looking for. We're using the same formula because of what is given, then we have the answer is that. Are we together? That means from there you're going to say what? P is equals to VI, which is 600, is equals to 220 I, then divide by 220 both sides, because what you do on the left you must also do on the right. Then from there, this 220 cancel 220. Then we have I is equals to 600 divided by 220. We have what? 2,73 ampere. Are we together, grade 12? Yes. And then it's easy because you already given, you were given the calculators, isn't it? Okay. Now let's go back to a question, the last question that says, if a unit of electricity costs a unit, that means 1 unit is how much? Is 1 rand 65 cents at an applied municipality. Calculate how much it will cost a family if they use the electric kettle for 15 minutes. Time that we're given is how much? 15 minutes. Are we together? Yes. Then we have this. We have this. What we're given? We were given that time is equal to 15 minutes. Changing time is 15 minutes. And what else are we given? We're given that 1 unit is equal to 1 rand 65 cents. This is what we're given. 1 unit is equal to 1 rand 65 cents. And then what we do is to do what? We first calculate the energy. Are we together? We calculate the energy. Where does this formula comes from? I don't prefer writing this formula like this. Are we together, grade 12? I want it as P is equals to W divided by change in T. Can you see? And then you write it as it is from the exam guideline or from the formula sheet. Are we together, grade 12? We don't take shortcut because that's why you lose marks. If you copy it like this, exactly like this, then you already have 1 mark. But if you write like this, you will miss that 1 mark that we give for choosing the correct formula. Are we together, grade 12? Yes. Let's write it like this, the way it's given in the exam guideline or in the formula sheet. Are we together, grade 12? Yes. Now, we say now, how much are we given for, we say power. How much is power that we're given? Is what? The power, remember. And then you ask yourself, where does this 0.6 comes from? The power is equal to the power that we were given. It was 600. Okay. And then in order to get it in kilowatt, we do what? To make it to kilowatts, we say divide by 1,000. And then now it comes what? 0.6 watts. Are we together, grade 12? Yes. That is why now we're going to say what? 0.6 is equal to W divided by what? We have 15 minutes. How much is 15 minutes in hours? That is one question also. Then we know that 15 minutes, we're going to divide it by what? We're going to divide it by 60, which is going to be what? 16 divided by is going to be 0.25. 15 minutes divided by 60, we convert it to what? To hours. Are we together? Because we said in seconds, electric circuit, we don't take time with seconds, but we're taking it with what? With hours. Are we together? Then we need to change this time into hours. Are we together, grade 12? Yes. Then now we're going to have a 0.25 like that. Then our energy is going to be, we multiply by 0.25 here and multiply by 0.25 here. Then this cancel this. Then we're left with what? W is equals to 0.25 multiplied by 0.6, which is going to give us how much? 0.15 kilowatt hour. This hour is this hour, And then this one here, it's supposed to be kilowatt. kilowatt. Remember, it was watt here, 600 it was watt, and then we divide by what? 1000 into turning it into kilowatt. Now, as a kilowatt, we have what? 0.6 kilowatt. Then now we have a kilowatt hour as our unit. Now, we're saying how much it will cost us. How much will cost a family if 1 unit is how much? Is 165. Let's see, the energy is what? Is 0.15. Then we're going to say what? Cost then is equals to 0.15 0.15 multiplied by this 0.115 is this one here. Are we together? Is 0.15 kilowatt hour, and we multiply by what? 1 rand 65. Then we have what? 0.25 is going to give us what? 0.25, which is 25 cents. That means if the family uses the kettle for 15 minutes and the kettle and the unit, 1 unit is equals to 165, that means they're going to use what? Only 25 cents. It will cost them 25 cents to use the kettle for 15 minutes. Are we together, grade 12? If you have any question, please don't hesitate. Ask. Are we together? Okay. Another question? Another question? This one, I'm going to give you 2 minutes just to copy it down. Copy the question down before we'll do it together. You're not going to do it alone, but we'll do it together. We will do it together. Next, grade 12. Let's take 2 minutes. Welcome back, grade 12. I'm hoping that you finished to copy the questions so that we'll be able to go through them. And it's nice to have the questions before you so that when you do the questions, you are able to refer back to the questions. The questions that we have now is, it says, in the circuit diagram below, the battery has an EMF of 12 volts. Ignore the internal resistance of the battery. That means the EMF here is what? 12 volts. Are we together? Then, number 1, it says, calculate the total resistance in the circuit. Grade 12, you can see here we have a branch of a circuit. We have these two that are in parallel, and we have this one that is in series with these two. That means for us to be able to calculate the total resistance, we need first to calculate what? The equivalent resistance for these two that are in parallel, and then so that we can end by doing what? Adding whatever was in parallel with the one that is in series. Are we together, grade 12? That is what we're gonna do. Then we go to 1.2. Calculate the reading on the ammeter. This is the ammeter, and this is the voltmeter. We have an ammeter, we have a voltmeter. Ammeter is for current, voltmeter is for potential difference. Are we together, grade 12? Yes. Now, let's continue. We say 1.2, we need to calculate the reading on the ammeter. 1.3, we need to calculate the reading on the voltmeter. Are we together? Then 1.4, we calculate the power of the 4 ohm resistor. This is the 4 ohm resistor. Are we together, grade 12? Then number 2, it says, will the ammeter reading increases or decreases or remain the same if the 5 ohm resistor is removed? If we remove this, will the ammeter reading increases or decreases or remain the same? Okay, let's see now. Number 1, can you see? We start by calculating what? The equivalent resistance of the two resistors that are in parallel of each other. Are we together? Then we use this formula. Are we together? Then we substitute. R1 is 5, R2 is 3. Can you see? Then we get what? 1,88. And then before we go to the final answer, I just want to show you how we get to this answer. First, you say 1 over Rp plus 1 over 5 plus 1 over, or equals to 1 over 3. And we say 15 here because it's a common factor for both 5 and 3. Then we say what? 5 goes out. 5 goes how many times into 15? It goes 3 times. 3 multiplied by 1 is 3. Then 3 goes how many times into 15? Goes 5 times. 5 multiplied by 1 is what? Is 5. Then we have what? 1 over Rp is equals to 8 over 15. Then from there we interchange. Then we say Rp divided by 1 is equals to 15 over 8. Can you see now? What was at the top now is at the bottom, and what was at the bottom is now at the top. That is how we interchange. Then we say now anything that divided by R by 1 is that. Then we have R. Then we have Rp is equals to 1,88 ohm, because 15 divided by 8 is 1,88. Are we together, grade 12? Yes. Now, because we have that, and then now we have what? We calculate that one also. Now we're going to use what? Series connection. Series connection, we say RT, total resistance, is equals to R, which is plus parallel, plus R 4 ohm. The one that is on the 4 ohm. Then we have what? RP, we found that is how much? 1,88 plus 4 ohm, which is gives us what? 5,88 ohms. Are we together, grade 12s? This is how we get what? The total resistance in the circuit. Okay, let's go back and then see. Number 2, it says calculate the reading on the ammeter. That means the reading on the ammeter. Okay. The reading on the ammeter is that we're using what? R is equals to V over I. But because the reading on the ammeter is total current, the ammeter will read the total current of the circuit. That means we need to use the total resistance and the total potential difference. Are we together? We don't be surprised when you see this T, small t that you see there. It means total. Are we together? Yes. Then now we know that the total resistance is what? Is 5,88, which is equals to the total voltage that is in the circuit. We said is 12 volts because it's equal to the EMF. Are we together? Is the same as what? The EMF. Then we have current T. Then we're going to multiply by current T here. Current T there, this cancel this. Then we're left with what? 5,88. 5,88 IT is equals to 12. Then divide by 5,88 both sides, because what you do on the left, you also do on the right. Then this will cancel this. Then I total is equals to how much? We found that I total is equals to 2,04 ampere. Are we together? Yes, that is our number 2. Let's go back and check number 3. Reading on the voltmeter. Reading on the voltmeter. The reading on the voltmeter, because voltmeter also reads the total voltage that is in the circuit. Then we're gonna say now, because now the resistor is what? Is we have 1 comma. We look at, let's go back a bit so that I can explain to you why I'm using 1,88 or 1,88. Look at the position of the voltmeter. Voltmeter is here. That means it can only take the, can you see? We're using this. We don't use 4 ohm because it's out of what? This. Are we together? The voltage that you see here, the ammeter here, it measures the voltage of 3 and 5 ohms. The resistors. Are we together? Yes, that is what I wanted to explain to you. Why are we using 1.88? Because remember, when we calculate the resistor, parallel resistor, we found that is what? 1.88. Now, then let's continue. Okay, this is what we have. Now, we're saying, we remember this formula, R is equals to V over I. Then R is 1.88, and then V is what we're looking for, and then the current, total current that is in the circuit, we said is 2.4. Then we say now V is equals to, how do we get to this? We multiplied here by 2.04 and here 2.04. This cancel this, and then we left with what? V, this side, and then 2.04 multiplied by 1.8, which gives us what? This. Are we together? Yes. Now, then the last question, our last question says, calculate power of the 4 ohm resistor. Calculate power of the 4 ohm resistor. 4 ohm resistor. This is power. Our power is equals to VI. Then we have 8,16 multiplied by 2,4, which gives us 16,65. Or we can use, I like this one, because we're using the formulas that we have as in an information sheet for grade 12. Are we together? This one, it says P is equals to I squared R. We know that our I, we calculated it as 2,04. Then we square that, multiply by 4, then we get the power to be 16.65. Are we together, grade 12? Yes. If you have any question, please WhatsApp us on 063 629 3655. 063 629 3655. Okay. Now, the last question it was saying, let's look at the last question. Will the ammeter reading increase, decrease, or remain the same if the 5 ohm resistor is removed? That means we remove this resistor, we remove all of this. That means whatever is moving is going to go through there, the voltage will move through there, the current will move through there. Are we together? Now, let's go back to our answer. Okay, let's go to our answer. The answer says the ammeter reading will decrease. Why? Because the effective resistance increases. It's like now we had, remember now, the total resistance, it was 5,88, okay, when we calculated it. But now because we'll be having only series connection, we're not going to have parallel connection. That means we'll have two resistors. It's going to be what? 3 and 4, which is going to give us 7 ohm. Are we together? That means the resistance is being, the total resistance of the circuit, if you remove the 5 ohm, then the total resistance will increase, not decrease. Are we together? It will increase because the one that you removed is the one that was parallel, and parallel it lessens it makes the resistance to be less. Are we together? That is why we're saying the reading on the ammeter will do what? Will decrease. Grade 12, this is homework for you. Can you please copy it down? I'm going to give you just 30 seconds to copy the question down. This is your homework. Do it at home.
Believe in yourself. Believe a little more in yourself. Because to those that believe, nothing is impossible. You have done this before. You have passed your tests before. You have went into a higher grade before. It is possible because you have done it before. Do not doubt yourself. Keep believing in yourself. Keep pushing because this can be done and you can be great.
Okay, grade 12, welcome back. Let me just go through the question again. An electric appliance with a resistance of 20 ohm draw a current of 12 ampere from a 240 volts. Can you see now you're given the resistance, you have given the current, and you're given what? The volt, the potential difference, which is the voltage. Are we together? Then they ask you to calculate the power rating for an electric appliance and the energy transferred. Remember the energy is that W. They ask you to calculate that W that is measured in joules. Like from this formula, we have PW over changing T. For this one here, they want you to calculate this W. Are we together, grade 12? Yes. Okay. Let's continue. This is a homework again. Can you please copy it down? I'm going to give you 1 minute to copy this down. It's another homework that I would like you to do at home as an exercise of what we're doing today. Grade 12, hope that you finish to copy down the homeworks and you'll be able to practice at home. And then you can always contact us on the WhatsApp number. Thank you very much for being such a good grade 12s, and hope that you enjoyed today's lesson. Please remember that the COVID-19 is not done with us, and then please keep the precautions. Thank you.